Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar. And today's topic for Cisco is configuring route redistribution between different routing protocols. So let's start. So we'll discuss the route redistribution. What do you mean by redistributing the routes? How to configure the redistribution between different routing protocols? Say you are running OSPF and EIGRP or RIP or BGP. So how to configure redistribution? So we'll explore the configuration of route redistribution between various routing protocols, and we'll highlight its definition, significance, and the essential steps involved in the configuration. So what do you mean by this route redistribution? Route redistribution means connecting different routing protocols. As we know that you can opt for static routing, and also you can opt for the dynamic routing protocols like the OSPF and EIGRP, but these two are different protocols. So if you are, say, configuring OSPF or configuring EIGRP or BGP, so is it possible to connect different routing protocols? Yes, it is possible. You have to configure redistribution, means you have to inject, say, OSPF into EIGRP or EIGRP into OSPF. It is a process of exchanging route information between different routing protocols. So two protocols are there, say there are two organizations, and you are mutually redistributing the protocols between them. This allows for interconnectivity and communication between networks utilizing diverse protocols. So it enhances the efficiency of the routing, because say company X is using OSPF and company Y is using EIGRP, they will not change the routing protocol. So in that case, either you can go for the static routing, that is the one solution. Another is you can keep that infrastructure in place and you can redistribute the protocols. Then what is the importance in networking in route redistribution? It is crucial in modern networking as it helps maintain seamless connectivity across varied network types. So it allows the integration of multiple protocols also, like by enabling protocols like OSPF, EIGRP, and BGP to share routing information. Route redistribution optimizes network performance because you are sharing the route to others, so you can mutually maintain the connectivity across diverse environment. What are the common routing protocols? Common protocols are OSPF, EIGRP, BGP. Also, there are the protocols like RIP, also like the routing information protocol, but that is almost obsolete now. So OSPF is a link state protocol widely used for IP networks, and it is used in enterprise networks, just like in EIGRP. Like EIGRP is also a hybrid routing protocol or an advanced distance vector protocol that we say, that combines the benefits of distance vector and link state protocols, and it making it scalable and easy to configure. BGP, it is used primarily for the ISP network and inter-domain routing, and it is essential for the functioning of the internet. So it carries a lot of network prefix, lakhs of network prefix it carries. So that is the purpose of using the BGP routing protocol. Then what are the configuration steps for this redistribution? So you have to identify the routing protocol first. First step in configuring route distribution is to identify the routing protocol. Now, which protocol you have to use? So if you're concerned with, say, the bandwidth, then you can go for the OSPF. If you're concerned with the number of NLRI or the updates there, you can go for the BGP. So if you're not concerned with too much bandwidth, but the stability, you can go for EIGRP. So knowing the characteristics and limitations of each protocol will aid in determining the most effective redistribution strategy. So first you discuss about the protocols, you decide which protocol to use in your routing environment, and then you redistribute. Either you redistribute EIGRP OSPF or OSPF EIGRP, or so OSPF BGP or EIGRP BGP, this thing. What are the use cases of redistribution and what are the commands? Once the routing protocols are identified, specific commands must be utilized. Now this involves the CLI to enable routes from one protocol to be advertised to another. So for example, in Cisco iOS, commands like router OSPF followed by the redistribute EIGRP. So you are actually redistributing EIGRP routes into the OSPF process. So that is why router OSPF process ID and then the redistribute EIGRP facilitate the exchange of routing information between OSPF and EIGRP. So you have to make sure that you are properly using the syntax to redistribute routes from EIGRP to OSPF and vice versa. Verification also you can do after configuring route distribution. It is very vital to verify. So for verification, you can use a command such as show IP route. Also, show IP protocol can be used to confirm that the distribution is correctly processing routes. So you have to check that whether the routing protocol is running, what are the routing protocol is running, and whatever number of the prefixes that is redistributed in the routing protocol. So you have to ensure that there are no routing loops or inconsistent routing paths or suboptimal routing is not happening there. So we can conclude that effective route distribution between different routing protocols, it is very essential for creating your robust infrastructure. And as the companies merge, it is more important because the companies will not change the infrastructure. It's not possible. So definitely the only solution is redistribution. And it is pivotal for network administrators to ensure smooth communication across diverse network environments by this redistribution. And you have to follow proper configuration practices and verification methods, and network can achieve efficiency reliability through this. So this is about what is the route distribution and its importance. And now I can take you to the Cisco packet tracer environment. As you can see that this is router is running the EIGRP, this router is running the OSPF, and this is the ASBR. So you can actually see that this is the EIGRP. So you can show IP interface brief, and here you can run the EIGRP router EIGRP1 network say 0000 any network your price, and here totally OSPF. Router say OSPF and process ID 1, and network here would be 20.0.0.0. There is a loopback. You can check with the show IP interface brief always. And I created a serial interface. So there I gave this network 192.168.2.0 and 000.255 area 0. So alternatively, you can check the IPs as show IP interface brief command. So it will give you 192.168.2.2 and 20.0.0.1 networks advertised there. So one is running EIGRP fully and one is running OSPF. Now what is about this ASBR? ASBR say 1.1, 192.168.1.1 is connected to this EIGRP and 2.1 is connected to OSPF. So it is running both the protocols serial 2x0 to the EIGRP and serial 3x0 to the OSPF. So what you need to do here, router EIGRP is number 1, network you're advertising as 192.168.1.0. Wildcard is not needed or mandatory here. Yes, it has found the adjacency. Also, again, exit, go to the config mode and router OSPF and process ID 1. Do not change the process IDs, otherwise it will not happen. So network, then 192.168.2.0 you are advertising 0.0.255 and area 0. So this is the you can say that this is the ASBR, and yes, the OSPF also is loaded. Now if you go to this ASBR and see the show IP route, it will show you the D for the EIGRP and also the OSPF route. Now if I can do the mutual redistribution here, what you can do, you go to this ASBR or autonomous system boundary router that is connecting two different routing protocols, OSPF and EIGRP in this case. So first say go to the router EIGRP and 1, that is AS number, and you inject the OSPF routes into the EIGRP system. So you can give redistribute, say you are redistributing OSPF and the process ID is 1, and then you give question mark and you can see that metric. You have to specify the metric as you are redistributing OSPF into the EIGRP. Is an advanced decision vector protocol. Metric is first of all bandwidth. Say bandwidth is 1000 Mbps, 1000 kbps. Then it is the delay. Say delay is a 255. Then it is load. So load maybe say it is 255. Give any metric, and then the say the you can say liability, and the MTU is say MTU is 1024. So now you have specified the metrics and you have redistributed OSPF into EIGRP. If you want to redistribute OSPF into EIGRP, then you have to specify the metrics. It is mandatory. Now do the opposite. Then go to router OSPF process ID 1, and here you redistribute EIGRP into the OSPF. So here you do redistribute, then EIGRP, and there is number 1, and here you can also see that the metric is there, but it is not mandatory. You can specify metric or metric type, whether it is internal or external, and metric you can change when redistribution, but I'm not changing here now. You have to specify subnets. Now, what is this purpose of this subnets word? See, if you do not specify subnets, it will work. In this case, it will work because it is using classful network ID. But if you are using classless, you are changing the subnet mask, it will never come, because to redistribute the classless networks, you have to use the subnets. It is mandatory. So here it is not needed, say, because we are not changing the default mask. But let's say I have used a subnets keyword. And now even you can see the show IP route here again. It will not be any difference here. But let's go to the other routers. Say the EIGRP here. And you see the routing information base or the route table. You can see now that the external route is coming. That is for the redistribution. This is it. EX, as you can see, EIGRP external route. So here you can see 20.0 and 192.162.0. That is the route from the OSPF that is injected as the external route to the EIGRP. And you can also view the show IP EIGRP and say you can say the topology or the neighbors. So let's say topology, and you can see all the routes, passive routes, all and you can see 20.0 and 2.0 that is also redistributed there, and you can see redistributed static R static. It is showing you this way. Also, let's go to the OSPF router here. Show IP route. As you can see, these two routes are external routes using the external to E2. External to routes that is injected, that is the 10.0 and 192.168.1.0. So that is the external to route. One is the E1 as the internal, and one is the external to route. So this is about the OSPF redistribution. That is the EIGRP is distributed into the OSPF. And if you can see show IP OSPF, let's say database, you can see that the type 5 is external LSA, that is the type 5 LSA that is injected into this OSPF domain by the EIGRP. You can see the 10.0 and 192.161.0 as the link ID, means the interface ID, interface network rather. Then the advertised router, that is the 1.2 that has sent this, that is the EIGRP router, and AH sequence, everything you can see. So that indeed verifies that definitely you are redistributing. You can also view the show IP protocols, and you can see that OSPF 1 and routing for networks. You can see this network 2.0 that is there. So it is its own network, and now redistribution is verified by this show IP OSPF database. Alternatively, you can go to the ASBR and you can see show IP OSPF database. And here also you can see the type 5 is external links test, external LSA that is present there. And also you can view the show IP protocols, and you can see the EIGRP protocol is there. You can see redistributing EIGRP1, the OSPF1. So you can see clearly that redistribution is happening here. And also you can see the routing protocol. Another is running, that is OSPF ProCID1, and it is also redistributing external routes from EIGRP1. You can clearly see that in this ASBR, we can indeed verify the redistribution that is happening here. So this is about the practically that you can do the redistribution, mutual distribution between the EIGRP and OSPF. Like this, you can do it between the OSPF and BGP, or EIGRP and BGP as well. Also, you can distribute static routes also into, say, any OSPF or EIGRP process. So this is a way to do the mutual redistribution between the routing protocols. So I think it's clear to you how to do the mutual redistribution, and it is very important in our enterprise networks, because in enterprise networks, as we see, diverse routing protocols are there. So definitely one routing protocol will not be there everywhere. So we cannot say that OSPF or EIGRP can be configured on every router in the world. So there will be different routing protocols running, and you have to definitely do the connectivity with the mutual redistribution when the companies merge or some new enterprises arise. So there the redistribution is only the way to make the connectivity. And this redistribution is a very important topic for your, say, CCNP NRC, as well as the CCNP NCore topic also, and for the CCIE also. And in case of CCNA also, it is not there directly in the syllabus, but yes, you have to grasp this topic also to do well in your examination in CCNA level also. So I think it will be very helpful for your studies for CCNA, and also for any course for CCNP, NRC, and core, even for CCI level. So I hope that you have got an immense understanding of this topic, and it will be helpful for your future studies and also for your career. So that is it. I have today about this route redistribution. That is a very important topic, and I hope that you will be able to implement it also in your enterprise networks as well. So that is it about the route redistribution topic for now. I again thank you all for joining and watching this webinar. I will come with some new topic next time. Till then, keep studying, and bye.